Hello students, today we are going to see a redox reaction. It is your unit 8 and I hope you must be knowing something about this term redox reaction. You have learned about redox reaction in class 10th in the type of reactions. Okay, so let us begin. And before that, I want you to know today what are the topics we are going to cover. So first we will be seeing the classical versus electronic concept of redox reaction, how the two definition works, okay? And then we are going to see what is oxidation number or oxidation state. Both are the same thing, okay? Then to find the oxidation number of any atom in a in a compound, there are certain rules to be followed. So that we are going to see what are the rules governing finding of oxidation state, and then we will be having a little practice and a little bit examples. We will see that how we came to the oxidation number. Okay, so let us begin. So as you are aware by the word redox, it is made up of two terms, isn't it? First is reduction and other is oxidation. You are well aware of these terms, right? So I will be giving you a quick revision of what you are already knowing, right? So let's see. Oxidation means we will be learning by, comparing these so that it will be easy to remember, because after some time we are learning, then we will get confused that what was the definition initially, right? So let's see. Oxidation means to any species, to any substance, to any atom, to any element, if oxygen is getting added to it, then we are saying that that atom or element is getting oxidized, right? So I will be writing the, your first definition that you are all aware of, that addition of oxygen, isn't it? When compared with this term, like related to oxygen, when we compare to reduction, it is, removal of oxygen from any compound, isn't it? Okay, fine. So let us see an example of it and then we can go ahead. We are purely speaking about oxidation and reduction, so these are not the example of redox reaction, okay? So if I gave you magnesium ribbon, that is a class 7th or 8th experiment you must have done, that if you are burning the magnesium ribbon in presence of oxygen, obviously it will make a salt, magnesium oxide. So let's write that. It is in solid form, so I am writing. So here you are getting MgO. So I'll balance it. Yeah, I think it is balanced. Yeah. So here the oxygen atom is getting added to the magnesium atom here. So we are saying that magnesium is getting oxidized. Isn't it easy? Yeah, you already know that. Okay. Then let's come to reduction. So I have mercuric oxide and I'm heating it. Okay. So I'm getting mercury plus oxygen. So again, to balance, okay. Okay, so here I have shown you the example of reduction and oxidation on the basis of, oxygen thing, okay. Now let's come to hydrogen part that you are already knowing, that it just works oppositely. Like here the oxygen has been removed. So in reduction, addition of hydrogen take place. Addition of hydrogen, okay, to any compound, right? Exactly opposite here, removal of hydrogen, right? Okay. So let us see another example defining these connecting to these definitions. Okay, so let us go with oxidation first. Oxidation means removal of hydrogen. Think of something where you can, think the hydrogen is getting removed. So I am giving you one fuel, methane, okay? You know that. CH4, in presence of oxygen, if I am burning it, I am getting carbon dioxide and water, isn't it? Okay, so here I'm able to see that, okay, obviously carbon is having covalent bond with hydrogen in CH4 in methane, and it is releasing its hydrogen. The hydrogen is removed, okay? The hydrogen is being removed from the species. So here we can say carbon is getting oxidized. Obviously here you can see oxygen is getting added also, so it is very apparent that carbon is getting oxidized. Okay, let us now go to reduction part. You are well versed of hydrocarbons, right? And the covalent bonds. So I'll give you one unsaturated hydrocarbon. Let us take ethene, okay? So when I'm adding H2 to it, okay, in presence of nickel and palladium, okay, so it will become saturated. The hydrogen will get added to the species, to this ethene, right? So this ethene will now be ethane. That's easy, right? So these were the conventional, the original definitions that you learned, okay? This was the thing. So now we have to come to the electronic part. So let's speak about the relation of electrons with these reactions. So can you tell me what is the nature of oxygen? Oxygen is electronegative or positive? Yes, it is electronegative because it attracts electron. Why does it do that? Because of its electronic configuration. If I'm simply writing it, so it will be 2, 6 as per the, atomic number, okay? Then octet rule and everything, you know that. So it needs 2 more electrons to fulfill its octet, fulfill its valency, right? So it is electronegative. So can I define that oxidation means addition of any electronegative electronegative atom to it? And here hydrogen, it is from group 1, okay? Group 1 alkali metals, it is, so it will have electropositive nature. Okay, so in general you can say if to some species, to a compound, to a atom, electronegative is adding, electronegative species is getting added, it is getting oxidized. Else, if electropositive is getting added, it is getting reduced. Okay, this was the conventional learning. So let us move to the electronic concept quickly. Okay. Again, I will be writing the same. It's so easy. Let us see now. So what is reduction? What is oxidation in terms of electrons? Okay, in the terms of exchange of electrons. Because it's all the reactions are happening just to, get the stability and get the electrons, right? So according to the electronic concept, if to any compound, any substance, any atom, any element, electron is added, okay? Electron is added. So we can say reduction is taking place, is happening, okay? And from any species, if I am withdrawing, the electron is being taken away, it is being withdrawn, so it is, we can say it has been oxidized, right? So removal of electrons, easily, simple. So let us see with an example, okay? I will be writing one redox reaction and we have to identify where the reduction is happening and where the oxidation is happening. So let us take an easy example, formation of your common salt, sodium chloride. You are well versed that it is an ionic compound, right? So it means the total exchange of electron is happening. Let's see now how it is happening. Formation of common salt. Okay, it's very, very easy. I'm taking sodium metal plus chlorine and you are getting NaCl. So to balance, what we need to do? Okay, fine. So sodium is a group 1 element, it is a metal, it is a highly electropositive species here, and chlorine is electronegative from group 17, you know that already, right? So let us split the reaction in form of reduction and oxidation, okay? So tell me, sodium is electropositive, right? What is its atomic number? Its atomic number is 11 and configuration will be 1s2, 2s2, 2p6, okay, and 3s, 1. Okay, yes, so it is a S block element and it will be releasing its valence electron to attain the stability, right? So I can say it will be releasing electron, right? It will be releasing electron, fine. Or we can simply remember this thing that sodium is a metal and metal are very much merciful. They give their electrons, right? They release their electrons, right? So I can write this thing as sodium is releasing 2 electrons. So I'm writing like this. I can write this, because sodium is releasing electron and getting ionized. So here the cation I'm getting sodium, okay, and 2 electrons are free now. Okay, these 2 electrons are consumed by whom? Chlorine, obviously. So let us see now. Cl2 plus these 2 electrons are going to be added here, and I'm getting 2 chloride anions, isn't it? So these way, these are the half reactions. Okay, so now we have to identify which one is oxidation and which one is reduction. Okay, I'll be giving you 3 seconds. 3, 2, 1. Easy, very easy. Now see, reduction means addition of electron. Where is electron is being added? I think chlorine is receiving the electron. Here the electron has been added. So I can totally say this is reduction. I'm writing here reduction R. And the sodium is releasing the electron, right? Removal of electron is taking place. So sodium is getting oxidized. So it is oxidation. Easy, isn't it? So now when I combine these two half reactions, okay, obviously, so I will get the whole redox reaction. Easy one, right? So this is the concept of electronic concept of telling redox reactions. Okay, so now I want to make you remember the, yeah, okay. So I had just a little bit catch in the internet. Okay, no issues. To remember this, we have a small mnemonic, how to remember that electronic concept of oxidation and reduction. We can use a word which is oil rig. Okay, rig means something like corruption or something. So you can imagine like that. So I will be saying oil rig. What does that mean? Yeah, it's easy. Oxidation means loss of electron, right? Easy. And reduction means gain of electron. Easy. So this way I hope we must have understood the concept of oxidation and reduction. When both the reduction and oxidation take place in a single reaction, we call it them redox reactions, isn't it? It's easy. So you compared them and you got the definition. So I will be doing a mark on this first topic we completed. Okay, let us come to the next part. Next part is oxidation number. So this was, sodium chloride was a ionic compound, and in ionic compound there is a total transfer of electron happening. But what about covalent compounds? In covalent compounds there are covalent bonds which are just the sharing of electrons. Okay, so in order to find the electron shift in a covalent compound, scientists came up with the idea of imagining that there is a complete transfer of electrons. It is not really happening, but it is happening. We are making it just for a easier understanding. Why? Because we have to assign them the oxidation states. What are oxidation states? I'll be telling you in just 30 seconds. Why they assigned a rule that we are imagining that there's a complete shift of electron in covalent bond from electropositive to electronegative. It is because to know the apparent charge on the atoms of a compound. Okay, so let us define what is oxidation number or a state. Okay, oxidation number, or we can call it as oxidation state also, the same thing. It is the charge or apparent charge. Why we are using this apparent word? Because for some covalent bond, coordinate bonds, we don't have proper charge, like there is no proper, complete transfer of electron, just it is apparent, okay? So it is the charge or apparent charge on an atom, no, an atom would have, we can say would have in a compound. Okay, easy one. Fine. Okay, now so we ended up with oxidation number. So there is a charge over atoms. Okay, why the charge will be there? Because they have charged subatomic particles, electron and protons. So definitely there must be some charge on an atom even when they are in a compound. So we will be knowing certain rules, how to find them, okay, how to find the oxidation number. Okay, so I hope you must have got this. We can move ahead. So there are certain rules which we need to follow. Okay. Rules governing oxidation number. So I can take a mark here because we learned this, right? So first thing is that if a if atom is if an atom is in its elemental form, in the elementary form or its allotropic form, the oxidation state, oxidation number will be 0. What does that mean? First is that if an atom is in its elemental form or allotropic, its oxidation number is 0. What does that mean? Because oxidation number means the charge is 0. Why? Because if I'm telling H2 exists as like this, the atomic molecule, it will not have any charge on it, no, because both are, there is no difference in their electronegativity or positivity, right? So there won't be any apparent or a real charge on it. So it will be having the oxidation number as 0. So we can have more examples like Cl2, sodium, magnesium, P4, like that. So these are the examples, like, the elemental form of atoms will be having 0 oxidation number. Now let's see the next rule. Next rule is that if a compound is neutral, okay, if a compound is neutral, so like as we know, NaCl, sodium chloride is neutral, they don't have any charge over it, right? It's not an ion, it's a compound. So the sum of the oxidation number of these two atoms will be 0 because they don't have any charge, right? This whole compound does not have any charge or apparent charge on it, okay? It is neutral. So in a neutral compound, the sum of the both of the, sum of the oxidation number of both the species will be 0. So if I'm saying sodium has oxidation number of X and it is having Y, so I can say X plus Y equal to 0. Okay, are you getting my point? Yeah, that's the second point. I think I don't need to write it because it's taking time. So we can move to the next rule. Okay, so let us go to the next rule. That the next rule is governed by the periodic table. You are well aware that the left side is, the left side of the table is having electropositive elements like metals. Okay, so the group 1, the alkali metals, right? S block element, alkali metals. Group 1 will always have the oxidation number of +1. Why does that? Why it's like that? Because the first group element have valence electrons one valence electron and they are ready to donate it. So it will attain a positive charge after donation. Okay, so they will have oxidation number as +1. Similarly, the group 2. Group 2 means alkali earth metals, right? They have 2 electrons in their valence shell. So obviously they will also be releasing it. So they will also have, in all the cases, they will have +2 oxidation number. Okay, yeah, it's easy. Easy? Okay, fine. So shall we move ahead? Okay. Now, let us see if any ion is there. We are speaking about, we just discussed about neutral compounds. Let's see about ions. So if I'm having a, you know, sulfate ion, right? So it has 2 minus charge over it, okay? So the overall, sum of the charges over on the atoms of these will be equal to the charge on the whole ion. Like what I want to say is the oxidation number of maybe sulfur is X, okay? So X plus, there are 4 atoms of oxygen, so 4Y will equal be -2. This we are speaking about, okay? So if an ion is having a charge over it, the sum of the oxidation number of all the atoms will be equal to its charge, okay? This is the next rule, okay. Now, let us speak about oxygen. You know, oxygen is very, very electronegative, right? And it has a valency of 2 electrons, but it accepts the electrons, isn't it? With atomic number 8, 2, 6 configuration, it will accept 2 electrons. But in most of the cases, it has minus 2 oxidation number, but just in 2 cases, it doesn't have the same oxidation number. What are the 2 cases? Let us decide. Peroxides and compounds with fluorine. How? Let's see. H2O2 is hydrogen peroxide. If I draw the structure like this, okay. Here in peroxides, oxygen doesn't maintain its capacity to attract the electron. It has one covalent bond in between and everything. So it has -1 oxidation number in peroxides. Okay. Now let us speak about fluorine. Fluorine is the most electronegative. So when compared the electronegativity of oxygen and fluorine, obviously fluorine will win. Okay. So if I am speaking about OF2, right? So the fluorine atom will have -1 oxidation number because it is going to accept the electron, 1 electron. So now how I will be saying, if it is X plus 2 into -1 and it does not have any charge, means so it has like this +2. So this happens just with the case of fluorine. Rest other than that, it will never ever have such oxidation number. Are you getting my point? Okay. Let's move ahead. One second, yes. Now let's speak about hydrogen, okay? Hydrogen and oxygen are very favorite of chemistry, right? So, hydrogen is there in the group 1. It is placed in group 1, okay? So, when it reacts when hydrogen is with some non-metal, okay, like, just take like chlorine. So, it is hydrochloric acid, right? So, when it will be with a non-metal, it will have a +1 oxidation number. Okay, this is very easy to get. It's very easy. Why? Because the other species is electronegative, so definitely it will behave like electropositive, isn't it? Okay, cool. And the last point is that fluorine has always 1 oxidation number. It will be -1 because it is most electronegative. Okay, so its oxidation number will always be -1. These are some basic rules. Now we can have some little practice. Let's do it. Okay, so we have completed the rules also. So I have marked a tick on it. So I will be giving you certain species, so certain compounds that you have to find the oxidation number, okay? So like, okay, MgCl2, we will be finding it, okay? Now next, okay, KMNO4. Rest, think of something. Okay, barium chloride, BaCl2. Okay, let us see this. Okay, let's see. So now you know magnesium is from group 2. Okay, it will always have, you know that, +2, right? So +2 plus. There are 2 atoms of chlorine, so I don't know, so I will be writing X. Okay, okay. So now it is neutral, so it will be having 0. So 2 plus 2x equal to 0. Now just do the maths, right? So the oxidation number of chlorine here is -1. It's easy to know. Now we know potassium. It is also from group 1. It will be having +1 on it. Oxygen is always having -2 except peroxide and fluorides. So now let's see. 1 plus X plus, because there are 4 atoms I'm doing, 4 into -2 equal to 0 because it doesn't have any charge over it. That is why. Okay. So 1 plus X minus 8 equal to 0. 1 plus X equal to 8. X is equals to +7. You know, manganese is a transition metal, so it will have multiple oxidation number that we will be studying. Okay, now let's see. Chlorine again, 17th group, -1. So X plus 2 into -1 equal to 0. X minus 2 equal to 0. X is equals to +2. So oxidation number of barium here is +2. Okay, that's easy. Now shall we discuss some ions? So this way it works. So I hope you will feel confident while taking out the oxidation numbers, right? So okay, so I want you to do for like SO4, okay, SO4 2 minus. So let us calculate the oxidation number of sulfur. So X plus 4. Oxygen will have -2, you know that, right? And the whole charge over it is -2. So I will be writing not 0 but -2. Solve it. X minus 8 equal to -2. X is equals to -2 plus 8. So X is equals to +6. Easy one, right? So this way it works, and oxidation number hold a very important significance in, many important compounds, agents, So it's very important to know the oxidation states, and there's a difference between valency and oxidation number, because valency is just showing your configuration, that how many electron you need to fulfill your octet. Either you have to release it or you have to gain it. But oxidation state tells about your charge in a particular compound. So according to the change of the compound, your oxidation state can vary. It can change. Okay. So like that. Thank you so much. I hope you must have got it.